We use functions to model how two quantities vary together, and in this course we use a convention called function notation to write function definitions. The process of defining a function using function notation involves the following: choosing a name for the function, often a single letter, deciding on the variable that the function will take as its input, and writing an expression or rule that expresses the function's output value in terms of its input variable. Upon defining a function in this way, we call the inscription to the left of the equality the output of the function. The entire equality is called the function definition. If we have defined a function using function notation, we can use the function definition to determine the output value of the function given a specific input value. For example, if the function f is defined by f of x equals x squared plus 3, then the output of f at 2, denoted by f of 2, can be computed by plugging the input value into the function rule. Therefore, the output of f at 2 is 2 squared plus 3, which equals 7. We call the process of determining the output value of a function given a specific input value evaluating the function. In this case, determining the value of f of 2 is referred to as evaluating f at x equals 2. Now, consider a circle whose size can vary. The formula c equals 2 pi times r expresses the circumference of the circle in inches in terms of the radius of the circle in inches. We can use function notation to express the circle's circumference in terms of its radius length by writing h of r equals 2 pi times r, where the input variable r represents the radius of the circle in inches, and the output h of r represents the circumference of the circle in inches when the radius is r inches. In this case, the name of the function is h. The input variable of h is r, which represents the radius of the circle in inches. The rule of the function is 2 pi times r, which expresses the circumference of the circle in inches in terms of its radius r. The output of the function is h of r, which represents the circumference of the circle in inches when the radius is r inches. Notice that h of r and 2 pi times r both represent the circumference of the circle in inches when the radius of the circle is r inches. However, it is much more convenient to write h of r than it is to write 2 pi times r, especially when doing so repeatedly. If we want to represent the circumference of the circle in inches when the radius is 2.3 inches, we could simply write h of 2.3. However, if we want to know the numerical value for the circumference, we must evaluate h at r equals 2.3. In doing so, we see that the circumference of a circle with a radius of 2.3 inches is approximately 14.45 inches. Similarly, we can evaluate h at r equals 13.25 to determine the circumference in inches of a circle with a radius of 13.25 inches. Now, let's look at the graph of the function h. For any value of r, the point r, h of r, is on the graph of h. For example, the point 3.2, h of 3.2, is on the graph of h. In particular, it is the unique point on the graph of h that has a horizontal component of 3.2. We can use this point on the graph of h to evaluate h at r equals 3.2 by looking at the vertical component of the point. This shows that the value of h of 3.2 is roughly 20.1. We can interpret this as the circumference of a circle with a radius of 3.2 inches is approximately 20.1 inches. In this manner, we can use the graph of the function h to approximate the output value of h given an input value.